Hey everyone, and welcome to today's explainer of some truly fascinating new metabolic research. We're going to be exploring a biological concept that is absolutely crucial to how you function every single day. I want you to imagine, just for a second, that your body manages its energy much like a highly advanced hybrid vehicle, right? A world-class hybrid doesn't just rely on one single power source. It shifts seamlessly and automatically between an electric battery and a gas engine, all depending on the terrain, how fast you're going, and the immediate demands of the road. Well, as you'll see, your body does the exact same thing with the food you eat and the fat you store.
Okay, let's dive into this, because it really is one of the central mysteries of human metabolism. Think about it. When you eat a super sugary, glazed donut, how does your body know to use that specific sugar right now? And conversely, when you haven't eaten for hours and hours, how does your system instantly know to tap into your stored body fat just to keep you walking, talking, and thinking? The answer actually lies in a perfectly coordinated biological switching mechanism.
And that switching mechanism brings us to our core concept today, defined right here by our source material, metabolic flexibility. It's simply the ability of your body to respond or adapt to conditional changes in metabolic demand. You can basically think of a metabolically healthy body as a finely tuned-up engine. It can instantly switch gears based on whether you're fasting, feeding, just resting on the couch, or engaging in intense physical activity.
Section 1. Fasting, Feeding, and Fuel.
To really grasp how this all works, we need to look at the daily, day-to-day operations of this hybrid system. Let's explore the two primary biological components that actually make up our power system during a standard day. Our internal hybrid vehicle relies on two main structures. First up, we have the skeletal muscle. This acts as our metabolic engine. It's the primary driver of fuel catabolism, which is just a fancy way of saying it actively breaks down and burns the energy to power your movements. On the flip side, we have white adipose tissue, or WAT. Now, historically, we kind of just thought of body fat as a passive storage unit, like a trunk, but the research shows it actually acts as a highly active, dynamic fuel tank. It constantly orchestrates fuel flux, buffering, and supplying free fatty acids to the rest of the body depending on exactly what the engine needs in that moment.
And this brilliantly illustrates exactly how these gears shift together. When you're sleeping or fasting, your body is firmly in fat-burning mode. Your skeletal muscle engine is running smoothly on fatty acids that are being released by the adipose tissue fuel tank. But look at what happens right after a meal. The gears shift, literally instantly. Driven by the release of insulin, the skeletal muscle drastically reduces fat oxidation and switches right over to burning the glucose you just ate. Meanwhile, the adipose tissue shuts off its release of fat and switches into storage mode to safely pack away any of that excess energy.
We can actually see this storage process happening in real time. Look specifically at the blue line here. This represents a healthy, lean individual. See those three dips? Those represent breakfast, lunch, and dinner. Notice how the blue line drops way down into the negative release territory after every single meal. That indicates that their fuel tank is successfully pulling dietary triglycerides right out of the bloodstream and storing them away safely and inertly. The whole system is responding perfectly to the influx of food.
Section 2. High gear. Exercise.
But what happens when we really rev the engine? When we transition from just resting to rigorous exercise, our energy expenditure can increase by an absolutely astonishing 25-fold. To support this massive increase in energy demand, our fuel tank has to mobilize energy incredibly fast. Interestingly enough, it's our abdominal subcutaneous fat, yep, that stubborn belly fat we all know about, that actually acts as the main provider of free fatty acids. The trigger for this whole process is epinephrine, which actually triples in the blood even during low-intensity exercise. This signals a crucial enzyme in our fat cells called adipose triglyceride lipase, or ATGL. Think of ATGL as the literal fuel pump that rapidly releases those fatty acids into the bloodstream to supply that working skeletal muscle engine.
You can see this incredible adaptability mapped out over a full 24-hour day inside of a respiratory chamber. Again, direct your attention to the blue line here, representing a healthy volunteer. This line is tracking the respiratory quotient, which basically tells us exactly what kind of fuel the body is currently burning. Notice how incredibly dynamic it is. It spikes sharply upward after meals when the body burns carbohydrates, and then it dips way down during sleep and after exercise as the body shifts back to burning fat. It's a perfect match for the physical demands of the day.
Section 3. When the engine stalls. However, this elegant system isn't exactly foolproof. What happens when this switching mechanism actually breaks down? Well, this brings us to the crisis of metabolic inflexibility. This is the underlying biological reality of conditions like insulin resistance, obesity, and type 2 diabetes. To really understand the breakdown, we have to contrast our healthy, tuned engine with an inflexible, flooded one. The research describes something known as the Randle cycle. In a metabolically inflexible state, excess lipids, or fats, essentially flood the engine. When too much fat is inappropriately present right there inside the muscle cells, it actively prevents the muscle from burning glucose. This gridlock is a primary driver of insulin resistance. The muscle refuses to take in more sugar because, well, it's already choking on excess fat.
So the crucial point is right here on this chart. Let's look at this again, but this time focus entirely on the red line, which tracks abdominally obese individuals. Remember how the blue line dipped down after every meal to store fat safely? Well, the red line barely even moves. This shows a stalled, insulin-resistant fuel tank that is failing to store dietary fat. Because the white adipose tissue essentially refuses to expand and safely sequester that fat, the lipids remain in the bloodstream and they end up spilling over into other tissues like the liver and muscle. It floods the engine and causes some pretty severe metabolic damage.
And here's exactly what that stalled engine looks like in terms of daily fuel burn. Check out the red line here. This is the metabolic profile of a patient with type 1 diabetes. Compared to that highly dynamic, spiky blue line of a healthy person, this red line stays consistently, stubbornly higher throughout the entire 24-hour period. What this means is the body is practically stuck burning carbohydrates. The system has become entirely rigid. It fails to shift down into that crucial fat-burning mode, especially at night while they're sleeping. The gears are just jammed.
Section 4. Tuning up your metabolism.
So if the engine is jammed, how do we fix it? Well, we have evidence-based mechanisms from the research to actually repair a stalled metabolism and get that flexibility back. Notice the sheer power of physical training here. This study flooded both trained athletes and untrained subjects with an acute oversupply of lipids, basically a massive dose of fat. Now, what's really interesting about this slide is the tall green bars on the left. The trained athletes perfectly adapted. Their bodies just ramped up fat burning to handle the overload while actually preserving their stored carbohydrates. But the untrained subjects on the right, they completely stalled out. They couldn't effectively increase their fat oxidation at all, demonstrating some pretty profound metabolic inflexibility.
The real reason trained individuals can handle that massive overload is because chronic exercise literally, physically remodels the engine at a cellular level. This isn't just about burning a few calories in the moment. Exercise creates true metabolic flexibility by physically expanding your mitochondria, the power plants of the cell, so they can handle significantly larger fuel loads. It enhances your capacity to burn fat, it improves how sensitive you are to insulin, and it even alters the skeletal muscle epigenome. You're essentially rewriting the software of your muscles to make them more efficient.
Which leads us to a massive so what moment from the source material. We so often equate just eating less with getting healthier, right? And it is true that calorie restriction-induced weight loss does improve insulin sensitivity, but, and this is a really huge but, calorie restriction alone does not enhance the skeletal muscle's actual capacity to burn fat. Only exercise does that. You cannot simply starve an engine into running better, you literally have to drive it, to force it to upgrade its machinery.
Section 5. The Master Clock. Circadian Rhythms.
Now, beyond just food and movement, our metabolism runs on a very strict internal timing belt, which is dictated by our circadian rhythms. As the American Heart Association states in their recent scientific statement, human physiology is partially regulated by the circadian system, which produces roughly 24-hour rhythms, adapted for daytime activity and nighttime rest. Basically, what this means is that our metabolic engine doesn't just react to what we eat or how much we move. It is quite literally programmed by the daily planetary cycles of light and dark to maintain homeostasis.
And here's a super surprising, highly actionable fact from that exact same Heart Association report. We always hear about getting our 8 hours of sleep, right? But sleep timing regularity is actually just as important as sleep duration. To keep this incredibly complex hybrid engine shifting smoothly between its fuel sources, going to bed and waking up at the exact same time every single day is just as vital as the total number of hours you actually spend asleep. Disrupting this clock disrupts your entire metabolic switching system.
So I think we have to ask ourselves, knowing that our bodies are these incredibly dynamic, flexible machines entirely designed to shift gears through eating, fasting, exercising, and sleeping, is your internal engine running on the right schedule, properly tuned by consistent sleep and regular exercise? Or, by living out of sync with your biology, are you just driving with the brakes on? It's definitely a powerful thought to consider as you go about optimizing your own routines. Thank you so much for joining me to explore this source material today, and I'll see you all next time.